So in this video, we're going to continue topic 10.14 about Taylor and Maclaurin series, and we are going to look at example 3b. So the Taylor series for f about x equals 1 has a radius of convergence of 2. Find the interval of convergence. So there is a little bit of a shortcut here that we had not talked about yet. Your interval of convergence always, I don't know if you notice this, when we get out of that ratio test, it's always the absolute value of x, or it's the absolute value of x minus c is what's really going on, and we technically force that to be less than 1. Well, in this case, our c value is going to be 1, so it's the absolute value of x minus 1, but we already know that the length of the radius of convergence is 2, so we say, hey, it's less than 2 instead of less than 1, so that way our length of our radius comes out to be the correct length. So I'm going to split that up by making it a -2 and a +2. And then we're going to add 1 to both sides, which would make it -1x less than, I'm going to add 1, 3. So there's my interval of convergence. I now need to test my endpoints just like I would have tested them before. I am going to come back up here, and I'm going to use this general term that we created to plug into. So I'm going to start with x equal to -1. So we know that that is going to be, and technically we really had the sum as n equals 0 to infinity there. So this would be the sum as n equals 0 to infinity of -1 to the n, -1 minus 1 to the n over 2 to the n times n. Well, if I start simplifying this, we'd end up with -1 to the n times -2 to the n over 2 to the n times n. And then if I simplified that a bit more, we'd have -1 to the n. I could split this up into -1 to the n times 2 to the n over 2 to the n times n. These would cancel. A negative times a negative would be +1 to the n is just going to be 1. So what I really have is 1 over n, which we recognize that as a divergent harmonic series. So this one is divergent harmonic series. So what that means is on my inequality, it stays open. Okay. Now we're going to substitute in our other values. So I'm going to go for x equal to 3 from the sum as n equals 0 to infinity of -1 to the n times 3 minus 1 to the n over 2 to the n times n. So this is the sum as n equals 0 to infinity of -1 to the n times 2 to the n over 2 to the n times n. These cancel. And what I end up with is an alternating series. So I'm going to do the alternating series test. So the first thing I look at is the limit as n approaches infinity of 1 over n, which is in fact 0. So condition 1 is met. Condition 2 is to make sure it's decreasing. So I start plugging in values. It's definitely decreasing to 0. So we know that this converges. So it converges by alternating series test. So in this case, we're going to add an equal to here on my interval of convergence.